Hello students. So in the last video we have discussed about the chemical properties of the D block elements. So in this video we are discussing much more chemical properties of the D block elements. One more thing I need to tell you is that at the end of this video I will be uploading the slides of the notes. You have to refer that notes and make a note by yourselves. I won't be giving any other notes to you. So you have to refer that slides that I'm uploading at the end of this video and make a note of yourselves, and you have to show it to me if I am asking you to send the photos of it.
Magnetic properties we are finding out whether a substance is paramagnetic, whether it is a paramagnetic or diamagnetic. Okay, we are finding out whether it is a paramagnetic or diamagnetic. If all the electrons present in that particular substance is paired, means we call it as substances which is containing paired electrons only. We call such substances as the diamagnetic substances, or those substances which is containing any unpaired electrons, then we call them as the paramagnetic. Okay, and normally a transition element is paramagnetic. It will contain any of the unpaired electron. Okay, so a transition element contains unpaired electron in their n-1d subshell. They will contain unpaired electron in their n-1d subshell. Hence, they are called as they are paramagnetic in it. But there are exception over there. Exceptional cases are there. Exception is there for certain ions. Certain ions like scandium 3 plus, then the titanium 4 plus, there are certain exceptional. Titanium, then copper Cu plus, copper ions, then Zn2 plus also. These are some of the exceptional cases over here. Scandium 3 plus and titanium 4 plus, both of them are having no D0. They don't have any electrons in their subshell. So hence what will happen? No, every electrons are paired. Right, then Cu plus and Zn2 plus. Again, when you check the electronic configuration of these ions, we will get a configuration of D10, completely filled D10. So again, here also what will happen? All the electrons are paired. Okay, in this case they will be exhibiting diamagnetic properties, else all the transition elements are paramagnetic. They will contain unpaired electrons in their shells. Okay, we can find out the magnetic moments. We can find out the magnetic moment of these substances, okay, of these elements. Okay, we can calculate the magnetic moment of these elements by using a formula. Okay, mu is equal to root of n into n plus 2. What is the unit? Bohr magneton. Bm, Bohr magneton. We will call it as the Bohr magneton. Okay, so we can calculate the magnetic moment of these elements by using the formula mu is equal to root of n into n plus 2. N into n plus 2. The unit is Bohr magneton, where n is the number of unpaired electron. Where n is the number of unpaired electron. Number of unpaired electron in that particular element, which is the small letter n. Okay, magnetic properties. Transition elements are paramagnetic in nature. Okay, they contains unpaired electron. Exceptional cases are there. So whenever you are getting whether substance is paramagnetic or diamagnetic, you just write their electronic configuration and check whether they have an unpaired electron or all the electrons are paired. So we will get that as whether it is a diamagnetic or paramagnetic. Next property is the catalytic property. Most of the transition elements and their compounds are having catalytic properties. They are having catalytic properties. Okay, what is the reason for the catalytic property of the transition element is that there are two main reasons for the catalytic properties of the transition elements. The first reason for that is the presence of variable oxidation state. Okay, because of the variable oxidation state exhibited by the transition elements, they can form a variety of unstable intermediates. They can form, we have studied about the intermediate formation using the catalyst, right? So the first reason is that they are having a variable oxidation state, and because of the variable oxidation state they can form a variety of unstable intermediate products. The next reason for the catalytic activity is the presence of large surface area. So what will happen? We have studied that the catalyst is working on a principle of adsorption, right? So since the transition elements and their compounds are having no very large surface area, adsorption on the surface will take place much more faster rate. So the it will facilitate the reaction process also. Okay, so the catalytic property, most of the transition elements and their compounds are catalyst. Their catalytic properties are due to main two reasons. First one is the variable oxidation state, right? Then they can form a variety of unstable intermediates. The next reason is that because of the large surface area of these compounds. Next property is the color. Okay, so most of the transition elements, even if they are in the solution type or else if they are in the solid state, both of them they are normally colored. Okay, so the transition elements, whether they are in the solution form as well as in their solid state, they are colored. The reason for that is that they are absorbing the visible light. The reason for the color exhibited by the transition elements is because they are absorbing the visible light. So what will happen when they absorb a light? We have studied that when a particular element, when they are absorbing the light, the electrons will jump from the ground state to the excited state, right? So the transition will take place over here. Okay, so when a particular transition element is absorbing light, what will happen means the electron will jump from, or it will get promoted from one orbital to another orbital in the same d subshell itself. It will be in the same d subshell itself. Normally it will be from the ground state, from the lower energy state to the higher energy state from the same d subshell itself. Okay, since the electronic jump or the electronic transition is occurring within the d orbitals of a transition element, they are known as dd transition. They are known as the dd transition. So it is because of the dd transition occurring in the transition metal. And how does it happening? It is because of the absorption of the visible light. So because of the absorption of visible light, they are appearing as the color. Normally the color will be the complementary color of the light which is absorbed by the element. Okay, so transition elements, whether they are in the solution form or in the solid state, are color. It is because they are absorbing the visible light. When an element absorbs the light, the electron will be promoted, or it will be jumped from the lower energy level. It will be from the lower energy orbital to the higher energy orbital. Okay, so say electrons are getting promoted in the same d subshell itself, so we call it as the dd transition. The other properties of the transition elements is that alloy formation. The transition elements have the similar radii. Normally transition elements are having similar radii and other characteristics also. There is somewhat they are similar. So what will happen means these metals can now mutually substitute their position in the crystal lattice and they can form the alloys. Okay, the alloys that is formed from the transition elements are very hard. They are normally hard and they have high melting point also. The examples of such alloys are steel. No, steel is an example. Then brass is another example. Bronze is another example of this type of alloy. Okay, so the transition elements can form alloys also because of their similarities in their characteristics. Okay, the next property that is exhibited by the transition elements is the interstitial compounds. They can form interstitial compounds also. Okay, so what is meant by interstitial compounds is that those compounds in which normally it will be in a crystal lattice. Normally it is a crystal lattice. So in a crystal lattice there will be lot of holes will be there. So in these holes small atoms can occupy over there. Okay, so these small atoms can occupy in the interstitial sites in the crystal lattice. So transition elements can form the interstitial compounds also because they are having the smaller sized atoms. They have the smaller atomic sizes. So they have lot of elements but the smaller atomic sizes is the okay. So they can easily occupy in the voids or the empty spaces in the crystal lattice. So they can form the interstitial compounds.